All right, so let's build the regressive feed forward neural network. So this is going to be a part of the unsupervised learning. So for this exercise, we're going to be using the Google's Colab project. So this is a browser-based programming environment. So you don't have to install, configure, maintain, and things like that. You can directly get to experimenting with the neural networks. We will use the example given by TensorFlow in the tutorial section. And first, we will do the example as is, and then in the next videos, we will change the parameters, use different functions, and experiment with this model. So this is an IPython Jupyter notebook. Perfect. For this exercise, we're going to be looking at the code from an operational perspective. So this is going to be much like driving your car. Car has many functions like the accelerator, the brake, the stick, and many other features. We know what they do, how to use them, but not necessarily the underlying mechanism, parts, and specifications, and so on. So we're going to take a look at this code from a functional perspective. We will see what each block of code does, not necessarily how it does it. And also, we will identify specific control blocks where really we want to spend more time tuning and experimenting with your neural network. All right, let's get started. So, we already have taken a look at the data. We know what the data looks like, and we also know what is the goal of this exercise. All right, so the first block here is basically importing the TensorFlow libraries, Keras libraries, NumPy library, and it's basically printing the version for your TensorFlow. All right, so this is how you run this cell, or basically you execute this block of code. So you gotta hit the play button, so you can see the version here. All right. The next block of code here, it deals with importing the Boston housing dataset, which is a part of the Keras library already, and it also is loading the data into two different sets, and it's also sorting the data. This is, of course, an optional but very good procedure. So let's do that as well. So let's go ahead and play this. All right, looks like the data is already downloaded. So the next block is basically you're printing the number of examples in your training data set and the number of examples in your test data set. Let's go ahead and print that here. There you go. So you got 404 examples in your training set, and you got 1 or 2 examples in your testing set. Now let's go down here. So this is where you actually print the data. So you're gonna take a look at the first record. So these are the 13 different values or features of your dataset. Now, if you want to take a look at the entire dataset in a nice formatted way, you can use the pandas library and take a look at it. Since you already understand the data from the Excel sheet, this might be an additional task. So this is how it looks like. So here df.head means printing the top 5 records. Now next is printing the labels. So this is what you want your feedforward network to predict on, and these are the values, and these are the median house prices. All right, next is also an optional task. This is the normalization stage, very effective, and some of the uses are it makes the computing much simpler, and it also brings in generalization, which is what we need. So let's use it. This basically is subtracting the mean of the feature and dividing by the standard deviation. Simple math, but of course you're using functions to do that for you. All right, so once the normalization is complete, this is how your data looks like. So no more 7, 3, 4, 5. As you can see from here, this is almost compressed within the space of -1 to +1. All right, now this is where you actually build your model. So I want to take you through this line by line. So you're defining class, and here you have a sequential keras model. So this is a deep neural network. So you have three layers. First layer is a dense layer. It has 64 neurons. The activation is value, and the input data shape is basically the data shape of your trained data, and it is one dimensional. The next layer is also dense. It also has 64 neurons, and the activation function is also value. The last layer is also a dense layer, and it has only one neuron because this is a regressive task. And in this task, we want to predict the median house price given a set of features. So this is just one value. So first you need to compile before you can actually run it. You basically call the function compile, and you select a loss function. In this case, it is MSE, which stands for mean squared error. The optimizer is RMS prop optimizer, and the learning rate is 0.001. And the metric is mean absolute error. So you're storing these details to some variables. All right, let's go ahead and run this and take a look at the summary. So this talks about the number of layers, the number of neurons, the parameters, and then the total parameters. Now this is the important block. This is where the training is going to happen. So for that to happen, you need to call the function called fit, and you need to pass the number of epochs and of course the data. So here's your training data, training labels, your validation split. This is the split within your training data, how much of it will be used for training and how much of it will be used for validation. So there are many more arguments which you can pass. We will take a look at that in a different video. This class is primarily just printing dots. All right, let's run this. So since the data set is very small and we're running 500 epochs, it happens rather quickly. There you go, that's it, it's completed. So let's go ahead and visualize this training. So for that, here they're using a library called matplot library. You're constructing a graph x-axis, y-axis, naming them, passing data. And you're also setting some legend and setting some limits. All right, there you go. This is the graph. On the x-axis, you have number of epochs. On the y-axis, you have MAE, or mean absolute error. And this is multiplied by 1000 to get the actual error in the dollar figure. So the blue trend, which you see here, this is the training loss during the process of training. And this is the green trend here, which is the validation loss during the stage of validation. All right, so you get an idea that during the training, the loss was almost less than 1, but during validation, the loss was hovering in between 2 and 3. So this is a normal behavior of a neural network. All right, so the next block is not necessary. If you want, you can run this. So you can use the evaluate function to understand the loss and the mean absolute error in numbers. Let's go ahead and play this. So as you can see here, the testing mean absolute error was $2,500. To actually understand this a little bit better, I have written some code. Let me just space it here for you. So what this is doing is basically this is printing the mean absolute error for the testing set, and then also is printing the loss for the testing set. Then it is also printing the mean absolute error for the training set, and also printing the loss for the training set. Right, so this is going to give us the big picture. Let's go and run this. As you can see here, the training set loss was much less. It was only 4.25, and mean absolute error was 1400. The testing set loss was 13.54, and the testing set mean absolute error was 2544. So what this means is that given a set of features, your feed-forward network has the capacity to make an error which is worth 2500. Next is, let's go and predict. So you're passing the test data after flattening it to the function called predict. So let's go and hit it. And this basically is telling you in a graphical format how your prediction worked. So yeah, as you can see, this is the regressed line. It's trying to reduce the distance between itself and the dots as much as possible. So let's also print the error. This is the error between the test labels and the test predictions. So how to read this graph is basically prediction error is on your x-axis and count on your y-axis. So for example, this bar over here, this one right above 5, so that means $5,000, and this error happened 2 times. So keep in mind also that the test label or the test set has about 1 or 2 examples. So all this is within 1 or 2 examples. All right. So now you can get an idea how the feed-forward neural network works for the regression example, and also you can gonna get an idea how the Jupyter notebooks work. In the next videos, we're gonna try an experiment by changing different parameters of the neural network.